Hello and welcome to Maths by Budhania sir. Today we are solving three very important assertion reason questions for the class 12th board exam. These questions are essential for scoring high and I will guide you step by step to ensure you understand them thoroughly. On this channel we are covering all types of questions you will encounter in the board exam, be it MCQs, case study, assertion reason and descriptive questions for 2, 3 and 5 marks. Make sure to watch the complete series of questions to fully prepare and excel in your exams. If you find this video helpful, don't forget to like, share and subscribe and hit the bell icon so you don't miss any updates. Pause the video, try the questions yourself, then watch the solution. Let's get started. In question 1, assertion is saying for matrix A which consists of elements cos theta and 1 where theta belongs to 0, 2 pi close interval and saying value of determinant of this matrix belongs to 2, 4 close interval. Now before proceeding to the reason, we will write here because. This because will give you a good sense whether the given reason is correct explanation of assertion or not. Because cos theta belongs to minus 1 to 1 close interval for every theta belongs to 0, 2 pi close interval. Okay, let's see cos theta when theta belongs to 0 to 2 pi. So we know the graph of cos theta, that is like this. This is 0, this is pi by 2, this is pi, and this is 3 pi by 2, and this is 2 pi. And on the y-axis, this is 1, and this is minus 1. So reason is saying that cos theta belongs to minus 1 to 1 close interval for every theta 0 to 2 pi. Yes, it is correct. So reason is correct. Now let's see assertion. Now it's saying value of determinant of A. So from here we find the value of determinant of A. Now to find determinant of A, we are considering first row. We will find determinant of A along the first row. So determinant of A will be equals to 1 into, that is 1 minus that is plus cos square theta minus, now along the second element, that is cos theta into minus cos theta minus cos theta, that is plus cos theta. Considering third element, that is 1, you will get plus cos square theta minus plus 1. So from here determinant of A is equals to 1 plus cos square theta. Now this will become 0. So from here we will get cos square theta plus 1. So determinant of A is equals to 1 plus 1, 2 plus 2 cos square theta. That is equals to 2 times of 1 plus cos square theta. Okay. So it is saying value of determinant belongs to this 2, 4 close interval. So what we have to find is range of this function. Okay, to find the range, we know that cos theta is greater than equals to minus 1 less than equals to 1 for every theta belonging to 0 to 2 pi. This we have already seen in the reason. So from here, what we have to do is to reach to this expression. Now on squaring cos theta, that is cos square theta, we know that the negative values will change to positive because square of any negative number is positive. So the cos square theta will lie between 0 and 1. Okay, now what we will do, we will add 1 to the whole inequality. From here we will get 1 is less than equals to 1 plus cos square theta is less than equals to 1 plus 1 is 2. Okay, but what we have to find is 2 times of this. So multiplying this whole inequality by 2. As we are multiplying this whole inequality by positive number, the signs of inequality will remain unchanged. So from here multiplying by 2, we will get 2. That is 2 times of 1 plus cos square theta, that is less than equals to 4. So determinant of A will lie between 2 and 4, 2 and 4 both included, and this is what it is saying. So determinant of A belongs to 2, 4. This is what assertion is saying. So assertion is also correct, reason is also correct, and reason is correct explanation of assertion. Why we are saying that reason is correct explanation of assertion is because we have raised this value using this value which was given in the reason. Clear? So both assertion and reason are true, and reason is correct explanation of assertion. So answer will be A. Clear? Okay, in question number 2, assertion is saying a line in space cannot be drawn perpendicular to x, y and z axis simultaneously. Here again we will write because for any line making angle alpha, beta and gamma with positive direction of x, y and z axis respectively, cos square alpha plus cos square beta plus cos square gamma is equals to 1. The reason is correct because we know that sum of squares of direction cosines is equals to 1. So these cos alpha, cos beta and cos gamma are basically direction cosines, and we denote cos alpha by L, cos beta by M and cos gamma by N. And we know this that L square plus M square plus N square is equals to 1. Okay, that is what it is saying. And alpha, beta and gamma is what? These are the angles made by the line with positive direction of x-axis, y-axis and z-axis. So reason is correct. Now assertion is saying line in space cannot be drawn perpendicular to x, y and z axis simultaneously. Suppose if we can draw a line perpendicular to all these three axes simultaneously, then alpha will be equals to 90 degree because it will make 90 degree with positive x-axis. Beta will be also 90 degree and gamma will also be 90 degree. So putting these values in this relation, we will get cos square 90 plus cos square 90 plus cos square 90. That will be equals to 0 plus 0 plus 0, that is equals to 0, and 0 is not equals to 1. So this relation is violated here. So assertion is also true. So assertion and reason both are true, and reason is correct explanation of assertion. We cannot draw a line in a space that is perpendicular to all the three axes simultaneously because this relation will be violated. Getting the point? So here also the answer will be A. Now in question number 3, assertion is saying for any symmetric matrix A, transpose of B into A into B is a skew symmetric matrix because the reason is a square matrix P is skew symmetric if transpose of P is equals to minus P. If we see the reason is correct because transpose of any matrix P is equals to minus P, then we say that the matrix is skew symmetric matrix. Clear? So reason is correct. Okay, now let's analyze assertion. Assertion is saying for any symmetric matrix A, this matrix is skew symmetric matrix. Okay, let's say Y is a matrix that is equals to transpose of B into A into B. So if it is skew symmetric matrix, then transpose of this whole should be equals to minus times of this or minus of Y. So let's see if it is minus Y or not. Okay, on taking transpose of Y, we will get transpose of B into A into B transpose. Now I hope that you know the reversal law of transpose. Okay, if you don't know the reversal law of transpose, then let me explain. Let's say there are three matrices that are in multiplication, and if we take the transpose of these three, that will be equals to, now we will write in reverse order, that is transpose of C into transpose of B into transpose of A, and this is known as reversal law of transpose. If you don't know, write it down as it is very important property of transpose of matrix. Okay, so from here what we can say is transpose of Y will be equals to, so now we know that the order will reverse, so it will become transpose of B into transpose of A into transpose of B transpose. So from here we can write that transpose of Y is equals to B transpose into, now watch carefully, what we are given that matrix A is symmetric matrix, and we know that since transpose of any symmetric matrix is equals to original matrix, so here transpose of A will be equals to A only, and we know that if we transpose a matrix and again take transpose, then it will become original matrix only, so it will become B. Now compare original and final. So here what we got, transpose of Y is equals to Y. So this is symmetric matrix, not skew symmetric. So assertion is wrong. So assertion is false, but reason is true. So option D will be the answer. Clear? Okay, here we end the video. If you like the video, hit the like button and share this video with your friends so that they can also get benefited. See you in the next video. Bye bye.